Namaste, a warm welcome to this video. So let us start with the next question. Question number 3. So consider the following x of t. So this is the x of t given. Okay. So let us say this is 0, 1, 2, 3, 4, 5 and so on. So this is Vm, this is x of t. So consider this x of t and find the average value for this x of t. The goal is to find the average value of this x of t. Okay, so solution, let us go to the solution. So first we need to find, so what is the t naught for this signal x of t, right? So what is the t naught? So t naught is the time for which the portion of the signal repeats, right? So what is that portion that is going to repeat for every time? So this is the portion that is going to repeat. You see, the same portion is repeating one more time here. So this is the portion which repeats for every 2 seconds. So therefore t naught is going to be 2 seconds. Okay, so once this is done, so let us apply the formula. So the formula is 1 by t naught, so integration over t naught x of t, so dt, correct? So what is this t naught now? So this is 1 by 2, so this is going to be 0 to 2 x of t dt, right? So we need to know, in order to get this overall value, average value, we need to know what is this expression x of t, right? Once we know this, so then the integrating this is very straight, right? So before we see what is the expression for x of t, so let us see the standard signal, what we know. Let us go to the next slide. So go to this. So let us draw the known signal. This is what we know. Right? So this is Vm and this is minus Vm. Okay? So let us call this is y of t 0, 1, 2, 3, 4, 5, 6 and so on. Okay? So now let us take one more signal. So for positive half cycle, let us take 1, and for the negative half cycle, let us take 0. Similarly, you take 1 for the positive and the negative for the negative, and for negative take it as 0 and so on. Okay, so keep repeat this and you multiply this. Let us call this is z of t with this y of t. Okay, so what we get, the output is, so the output t now, so this is the time axis t, so this is going to be, so 1 is going to multiply with Vm, so Vm will be as it is, and if you take this, this is going to be 0, 1, 2, 3, 4, 5 and so on, right? So this is going to be, so 0, 0, so wherever we have a negative pulse, so that will be multiplied with 0, therefore the overall answer is going to be 0. So therefore this is 1, and 1 to 2 it is going to be 0, so once again from 2 to 3 it is going to be a pulse, and 0, one more pulse and so on, right? So therefore this is going to be Vm, this is 3, 4 and so on. So let us call this is now, so this is the signal what we need, right? This is the required signal, this is the required signal x of t. So now in order to get x of t expression, so first we need to know, so what is the expression for y of t? So what is this now? So this is Vm sine omega naught t, right? So what is omega naught? Omega naught is nothing but 2 pi by, so t naught. What is the t naught here? So this is the t naught, right? So this is the portion that repeats for every time. So what is the time at which it repeats? So the time t naught is going to be 2. So therefore this is pi radians per second. Okay, so therefore x of t now, let us write here, therefore x of t expression is going to be same as y of t. So this is Vm sine pi t. Okay, so once we know this x of t, so all we need to take the integration. Let's go to the next slide. So therefore So this is 1 by 2, correct? So 0 to 2 x of t dt. So let us see here. This is what we need to find, right? 1 by 2, 0 to 2 x of t dt. Okay, so let's to move here. So let us go to the next page. Yes, this 1 by 2 from 0 to 1. What is the expression we have? So this is Vm sine pi t, correct? So what about from 1 to 2? So 1 to 2, that signal is going to be 0 into dt. So here we have dt, right? So therefore this is 1 by 2. So Vm will be constant. So the integration of sine is minus cos pi t by pi. So for the limits, the limits are from 0 to 1. Okay. So therefore this is minus Vm by 2, right? So pi is constant here. So this is cos pi minus cos 0. So which is going to be minus Vm by 2 pi. This is minus 2, correct? So 2 gets cancelled. So minus minus becomes plus. The overall answer is going to be Vm by pi. Okay. So this is the average value for the given x of t. So let us go to the next page. So the summary here is, so the given signal x of t, this is the given signal x of t, right? This is 0, this is 1, this is 2, 3, 4 and so on. This is my Vm x of t. Okay. So the average value, so this signal we call, this is the output of a rectifier output. Okay. So for this, so we got the average value Vm by pi. Okay. So this is the average value for this particular signal x of t. Okay. So let us go to the next slide and let us ask the question. So what if I just place the same signal? What if I place the same signal, but if I change the axis, time axis, right? So let us say instead of 1, if I put, this is 0, this is pi, this is 2 pi, and this is 3 pi, and so on, and this is Vm. Okay, this is now x of t. This is the next question. Okay, the question is to find what is the average in this case, average value of x of t. Okay, so what is the average value here? So solution, same. Let us proceed to the same procedure. So the first one is to find what is t naught. So what is t naught? So the t naught is going to be 2 pi seconds, correct? So this is the portion that repeats for every 2 pi. So therefore t naught is going to be 2 pi. So then the average value is going to be 1 by 2 pi, 0 to 2 pi, correct? 0 to 2 pi. So x of t dt, correct? So let's go to the next slide. So let us consider the standard signal. This is the standard signal we have, right? So this is 0, this is pi, this is 2 pi, right? And this is going to be 3 pi and so on. Let us say this is Vm and this is minus Vm. So this is y of t. So take one more signal with a different color. So this is t with pulses. So it's a pulse signal. 1 for this 0 to pi, and from pi to 2 pi you take it as 0, and from pi to from 2 pi to 3 pi, so take it as 1 once again and repeat. So this so this pulse will repeat like this. Okay, so take this pulse signal 2 pi, 3 pi, okay, and multiply with this, so y of t. So this is called z of t. Okay, if you multiply these two, so what we get now is, so this is the signal we are going to get. Okay, so this is 0, this is pi, this is 2 pi, this is 3 pi, and so on, right? This is going to be Vm. So therefore, the x of t now is going to be, therefore x of t is going to be same y of t. So it is going to be same y of t. So that is nothing but, so what is this now? This is Vm sine omega naught t. What is omega naught? Omega naught is nothing but 2 pi by 2 pi. Therefore this is 1 radians per second. So therefore this is Vm sine t, right? So once we know the x of t, so just get the integration. So the integration is going to be 1 by 2 0 to, yeah, it is going to be 2 pi, right? Let us go back. Yes, it is going to be 2 pi. This is 2 pi 0 to 2 pi. So x of t is nothing but, what is the x of t we got? Vm sine t, right? This is Vm sine t into dt. Okay, so 1 by 2 pi will be as it is, it's a common. So 0 to pi, this is Vm sine t dt, right? Whereas from, so this is pi to 2 pi, it is going to be 0. Okay, so therefore this is 1 by 2 pi. So Vm is going to be constant. The integration for this is minus cos t, right? So limits are from 0 to pi, and this is going to be 0. So 1 by 2 pi. Okay, so Vm will be here minus Vm. So this is cos pi minus cos 0. Okay, so what is this? The final answer is going to be, so minus Vm by 2 pi. This is going to be, so minus 1 minus 1. Okay, so this is going to be Vm by pi. Okay, so what is the observation from these two problems? The observation is that, so the average value is independent of the time, right? If you take just, so this is a summary. This is a summary. So take the first problem. This was the first problem, right? This is 0, this is 1, this is 2, this is 3, and so on. Here it is, this is Vm x of t. And similarly, we have changed this time axis, right? So time values to 0, pi, and this is 2 pi, this is 3 pi, and so on. Okay, so Vm. So in both cases we got the answer is same. In both cases the answer was, what was the answer we got? So the answer was Vm by pi. So therefore the average value is independent of this time. Okay, so the time can be any the value of time can be anything. Okay, it doesn't matter. So what is this time? It only depends on, so Vm, that's it. Okay, so that is a main observation point from these two problems. Okay, so that is what we got as Vm by pi. So therefore, so this is the off-air rectifier output. So off-air rectifier output average value is going to be Vm by pi. So with this we'll stop the video here. So next time when we meet, we'll come up with a new problem. So till then, take care. Namaste.